I'll start out with a quote. 80% of all PFAS can be easily replaced by existing technologies and materials if we had all the money and time in the world. That quote, that is from me, and it's based on my gut feel. So just a little bit about me. I have a PhD in materials chemistry from Aarhus University, and now I've been 4 years as a consultant at the Danish Technological Institute. I'm mostly a consultant. People often confuse the DTI with a university. We are much more close to the industry, actually helping them implement good alternatives, substitution chemistry, doing a lot within the circular economy that we just heard about before. So what I've been doing, I've been developing a recycling method for wind turbine blades. I think it's a good analogy to the PFAS debate here today, because when we started doing that, everybody was saying, stop, we have developed wind turbine blades to be durable and to last forever. You cannot take them apart. And after 1 year, we have developed a readily scalable technique where you can recycle the epoxy resin and you can recycle the glass fiber and put them into new wind turbine blades. So apologies if I'm a little bit reluctant on, this is not possible. I've seen when industry comes together, everything is possible. Then I've been a lot a chemical detective, companies saying, well, what is this particle I found in my production? Sending a taxi cab to my workplace and then working all evening to figure out what it is, because it's expensive to have production stops. And then lastly, for the past 2.5 years, I've been mainly focused on PFAS. So just setting the scene for today, I'm going to give the overview of why PFAS is a legacy product, that the supply chains are not transparent, and lastly, that companies have different types of PFAS issues. And I'm mainly concerned about the fluoropolymers. I'm not exclusive to fluoropolymers, but just have that in mind when you hear me speak if there is any misconceptions. So what I've seen over and over again, and I've helped a lot of companies by now implement good alternatives to some of the fluoropolymers, is that they're over-engineered. And we have had the fluoropolymers for over 60 years, or 80 years actually, and everything in our industry has been built up on the opportunity to use fluoropolymers. So everything is designed to use fluoropolymers, and if you're an engineer or a designer and you want your product to work, you use fluoropolymers. So this is why we have so much fluoropolymers around in the industry. And PFAS and fluoropolymers have a lot of very, very good properties. They can do it all. I mean, they have a low electrical conductivity. They have some special mechanical properties, a very good chemical resistance, very good resistance to temperature. They can do it all. And we are not going to find a one-to-one substitute. First of all, there's over 10,000 PFAS, right? I mean, we cannot find a one-to-one substitute for 10,000 chemicals. But on the other hand, from a very chemical carbon-fluorine bond perspective, you're not going to find anything that can do everything at once. So the main focus areas when we're looking for good alternatives is to identify what is actually necessary. Because in most products, as I say, they're over-engineered. You don't need all of the properties at the same time. Because if you don't need the mechanical properties, there's a lot of good plastic materials and alternative materials that can fulfill these requirements. If you don't need the chemical resistance, there are other materials. If you don't need the temperature resistance, there is third materials. And again, you're also going to get these slides, but feel free to take a picture as well. So this is kind of my view on when we're going to find alternative, we have to sit down and first figure out what is the requirements of our products. Before we do that, we're not able to find a good alternative. And just to visualize what I mean, if we have taken PTFE or Teflon as an example, I believe that we can find a lot of good alternatives, but we're not going to find one. We're going to find several materials that can fulfill areas of uses of these fluoropolymers. This has already been mentioned before today, but I just want to emphasize that again, that one of the largest problems for the industry is, I mean, before you can even start to substitute PFAS, you have to figure out where it is. We have also heard that there's not a lot of knowledge about PFAS outside of Europe. So actually figuring out where you're using PFAS in the products is an issue that I help a lot of companies figure out, and it's very, very difficult. So before we can even start substituting, we need to figure out where it is. This is more highlight of a problem rather than me having a concrete solution. We have some AI models that we are developing together with an American company that is starting to be able to do this automatically. I'm happy to share about that in breaks or after the meeting today, if you're interested. So getting down to the different type of issues that I see the companies are having. So basically you can use PFAS for a property, or you can use PFAS for its diversity. And this is where I think the communication between legislation makers and industry are often going in the wrong direction. So this is kind of my passion to highlight this, because I think it helps aid the discussion about PFAS phase out. So when you use PFAS for property, that is when you are looking up PFAS uses on Google, right? You get all of these diagrams and where PFAS are used in products. And good examples are you use it in textile impregnations, you use it as an anti-foaming agent because it's very good at sustaining a great foam for a long time. You use it for its non-stuck stick properties in cookware pans and so forth. This is where you can say, this is why we're using PFAS here. On the other hand, and the much more complicated subject is when you use PFAS for its diversity. So by using PFAS or using a fluoropolymer, you can have a product that you use in a coffee machine. And in that coffee machine, the fluoropolymers, I mean, they are resistant to oils because there's oils in coffee. They are resistant to temperature because a coffee machine is hot, right? But at the same time, that specific component is also used in a water pump, in a medical device, in a car engine, in an oven, in a dosing pump. And all of these application areas have different requirements, right? So this is kind of the problem that, I mean, we can easily find a substitute for this product, for the PFAS used in this product, where it's used in a water pump. But if we do that, then we end up with product A. That is the product you see here in the middle, right? So instead of being able to use that in a lot of different applications, you figure out one single alternative for every single application that is used. And then you're going to develop a lot of products. You're going to have a very complicated product portfolio. And basically, the time and investment required to do this for every single application is not something that even if we gathered all the scientists in the world, would be something that would be easily done within the next couple of years. So we need to look at the PFAS alternatives on a different viewpoint than a one-to-one substitution. So the thing that I'm mostly concerned with right now, and we are currently gathering an industry collaboration in Denmark in collaboration with the Danish EPA, and that is, we need to identify these areas where we say, here we can find one or two materials that will be a good replacement for 90% of the uses within this category. Because if we are looking at it individually, again, there's not a lot of time in the world. And that could, for an example, be like, we have a lot of applications where we have heat and low friction, right? We have actually found a very good or very promising candidate for that. That is PEEK with 30% graphite. Because where you need a high heat tolerance and a low friction, it's usually because it's a seal and you don't want it to wear very quickly. The problem is Teflon is actually not very good at sustaining wear. So choosing a harder material, PEEK, with 30% graphite, reducing the friction significantly, you have a product that is able to withstand a dry, slide and tear application for actually a lot longer time than the current PTFE solutions. So this is the kind of categories that we are currently looking into. What should they be and how are the alternatives going to look within these categories to kind of hopefully get out some white papers and help the industry implement alternatives faster. That was all I had to say. I'm on LinkedIn if you want to stay in touch, and I'm happy to receive any questions.
Thank you so much. That was excellent. I think we have time for just one question. I see someone in the back who already got their hand up, so we'll get Mike back to you.
Hi, my name is Pierre Bonnen. I come from a PTFE manufacturing company. Fantastic presentation, by the way. It's one of my goals from last year and this year. What else could we do? And you put it so well, how to replace PTFE is impossible. So my question to you is, what's your suggestion to your manufacturing company to replace a chemical such as PTFE?
Yes, so I mean, you see what is coming, and you see the industry is asking for alternatives, right? So what I'm usually saying to manufacturers as yourself is, again, if you identify, if you help the companies identify these areas where you say, okay, let's produce PEEK and actually scale up the production of PEEK, because PEEK is incredibly expensive right now. I mean, it's a really horrible process to make PTFE and very complicated. The only reason it's cheap is because we've really been able to scale the production to a high volume. What if we do the same with PEEK and say, now we figure out these areas where if a customer comes to us and say, we have a seal, it's in a dry slide and tear application, then you can say, we have a good solution for that. That's PEEK with 30% graphite. That would be my suggestion. I'm not saying it's easy. I really want to emphasize this. I think all of us in here acknowledge that it is a very complicated problem.